Excuse me. Oh, fun times. Yeah, I know.
Why did you come to school today?
Because I'll be gone tomorrow for the math team competition, and I'll be gone on Wednesday for a books thing that I have to go to. So I'm gone 2 days already this week, and I can't miss a third. So, believe me, I would have much rather try to get healthy for all of this stuff, but I gotta go to this other stuff on Wednesday. Basically what I wanna do is work through simplifying stuff like this. This is just polynomial divided by polynomial, which basically means you're gonna be factoring all the time. My suggestion, as you're going to write these problems down, factor them as you're writing them down. Don't write down the problem, write down the factored form. For example, what times what's negative 12 you add together to get negative 4? Negative 6 positive 2. So I would write down, as I'm simplifying this, I'd write, oh, that's x minus 6, x plus 2, over x plus 2, x minus 4. I'm sorry, x minus 3. What simplifies?
X over 6 over x.
And you wind up with x minus 6 over x minus 3. Now, one thing I want you guys to remember, you can only simplify these things like that because it's multiplication. You cannot simplify over addition. I cannot say my answer here is 3.
Got it.
Okay? Cannot simplify over addition. You have to simplify terms. Okay? That's what a lot of this stuff breaks out to be. I know you've probably done a little bit of this before. It's nothing too crazy. But not only will we see them where they write them out like this, some of them will get to be a little bit long-winded, where you have to simplify and multiply all at the same time. What I would do, again, first thing I would do is as I'm writing the problems down, I'm factoring it as I'm writing it down. It just saves me a little bit of time. Okay? Saves me a little bit of time. Put it in your pocket or put it out in your locker. Thanks. First rule of factoring. You take the GCF out, we get a 4x and x minus, 1 minus x. You okay with that? On the bottom, we have, what's that, x plus 3, x minus 1. On the top, x plus 3, x minus 2 over 4x. What drops? 4x goes. X plus 3 goes. Let me show you what happens. You have a 1 minus x, x minus 2, and an x minus 1. How can I turn that, bless you, how can I turn a 1 minus x into an x minus 1? What can I factor out of it? Negative 1. If I take a negative 1 out of that, it's a nice little trick. A lot of times you'll see that when you see inverted values of one another, 1 minus x, x minus 1, something along those lines. If you take a negative 1 out, then you'd get negative 1 plus x, which is x minus 1. So your answer then would just be negative 1 times x minus 2. Or if you distribute, you can write it as t minus x if you want. It's not a big deal. It's all about simplifying before you multiply. Do you remember the rule of division when you're dividing fractions? Yeah, flip it, yeah. You flip it. All you do is multiply by the reciprocal. That's all it is. Division is the exact same thing as multiplication. When you write it down, you just flip whatever you're dividing by. For example, sorry guys, I'm really sorry.
It's alright, it happens to the best of us.
Thank you for your support. So, as I'm going to write this down. 5x, can't do anything. What can I do with 3x minus 12? drop your GCF with a 3. Now, I'm going to flip the second fraction, so what times what's 8 you add together to get negative 6?
Negative
4,
four,
negative 2.
Negative 4, negative 2. And then what do I do to the new denominator?
You get factor out next.
And dun dun dun.
Five over 3. That's next.
What's that? How do we get rid of the x?
I
They
got
both
you.
had x's. Okay. This should be really easy.
So the first one, do you not change it? Like, or is it just because it was 5x? Okay, you didn't change it.
You don't change it because you're not dividing. You change what you're dividing by.
Oh.
When you divide by a fraction, you multiply by yourself. Yeah, go.
Why do you flip it? Why do you put the bottom on this division?
If I say this, if I divide something by 2, 4 divided by 2 is 2. I'm assuming you agree. 4 times 1 over 2 is also. That's
Yeah.
fine. Dividing is the same thing as multiplying by every circle. It's just quicker. What's underneath that you don't see? Don't forget that. I'm not going to worry about it. Just sometimes I throw that out. Let's do this one. When you see one where you have multiple parts to it, when you have the multiple parts,
What?
you have an x
I don't like
over x
this.
plus 5 times the 3x minus 5 divided by 9x squared minus 25 all over x plus 5. Well,
The first two is the same.
the first two are the same, right? What do I put this one over?
1.
1. So I know, as I'm writing this down, I can't factor anything. And then I'm going to flip it right away. And I get an x plus 5. Isn't that a difference of squares?
Yeah.
So you get 3x minus 5, 3x plus 5. And then you just start simplifying out groups of 1.
The second one is dividing.
This one is.
Yeah.
This one was multiplying.
The next one down.
I flipped it. Yeah,
You
I
flipped it.
flipped it here.
Okay.
I flipped it there, so you wind up with x over 3x plus 5. And you cannot simplify the x's out because of the addition in between. Okay? So that's 9-4. As you can see, it has a whole lot, not a lot of comparison to what we were doing with graphing. Yeah, I know. It's a little bit nicer. So let's look at the other stuff, the 9-5.
Was it x over 3x plus 5? X over 3x plus 5.
I'm sorry, guys. Once this loads, what's going to happen now is this is where I want to spend a little bit more time on, is working with fractions and adding and subtracting. When you add and subtract fractions, what do you have to have? You got to have a common denominator. Okay. Now, a lot of times when you work to get your common denominators, you guys found that you would just multiply the two parts together and figure out what it is. For example, here, what would be the common denominator between a 3 and a 2? 6. So what you guys would have done was, bless you, turn it into a 6. What do you have to multiply the 3 by to turn it into a 6?
2.
So you're multiplying the top and the bottom by 2 over 2, which is a factor of 1. You're just changing shape. You're multiplying, when you get to getting common denominators, what you're doing is you're going to multiply the fractions together by some factor of 1, bless you, which just changes the shape. So you'd have 4 plus, well, this you have to multiply by 3 over 3. Then you get 7/6 if you add those two together. I know that you guys have all done that. They might have shown you that for 1 minute and said, oh, just use the button on your calculator. Well, you really can't use a button on the calculator when you're doing stuff like this.
Yeah, probably not.
Probably not. But what can you say right away about both of those problems?
Got the same
They have
GCF.
the same denominator. So if they've got the common denominator,
So it's just 9.
you just write it down. What's 4 plus 5?
9.
Can I simplify that?
Yes.
What do you get?
3
And you're done. Okay. Same deal in the next one. Do you have a common denominator?
Yes.
What is it?
X plus 3.
Write it down. Is there anything you can simplify?
No, there's not.
You're done. And you're done. Okay. The wackiness and or the weirdness of this is when you start having to get the common denominator. So that's where most people start to mess up a bit. Let me get some more. For example, as you get into ones like this, as you write down these problems and you know that you're not going to have common denominators, I want you guys to try and factor everything you can right away. As you're writing it down, you always want to factor so you can look at all of your terms that you have in the denominator. So, fraction on the left, there's nothing I can do. So it's 5 over 6x squared. Here, GCF-wise, I have 4x, and I have then x minus 3. Everybody okay with that? So, what we need to do is figure out the least common denominator as you walk through those. You guys all remember how to find the least common denominator with numbers, right? What's the next smallest number that 6 and 4 both go into? 12. Okay. X and x squared, what would be the common denominator? X squared. And then I have that other term of x minus 3. What I'm doing here is I'm pulling apart the chunks to get the common denominator. And that's all there is to it. Okay. Then it's just a matter of, okay, what do I multiply 6x squared by to turn it into a 12x squared times x minus 3? Well, it's 2 and x minus 3. So the top becomes 2x minus 3 times the 5. What do I do with the other x? Same idea. I have to multiply it by x times, well, this one had a 4x and an x minus 3. How do I turn 4x into a 12x squared? I need a 3x. I didn't need the x minus 3 because it was already there. Okay. And now let's distribute and combine like terms.
X minus 3, gone.
Oh!
Oh.
Can't do that. It's a plus sign between the two. Can't do that.
You
Alright.
thought.
So you have 10x minus 30
Oh, I got it now.
plus 3x squared all over, what is that? 12x squared. Okay. I'm going to put that in a descending order. Every once in a while you might get something that you can factor. It doesn't happen all the time. I mean, you can always check real quick. What times what's negative 90 that you can add together to get positive 10? Sure.
I don't understand
Smallest value you can go into. You remember how to do the 6 and 4, right? What's the next number they both go into? 12. And then you go to the next part. One of them has an x and one has the x squared. What would be the common between the two? x squared. You gotta go up a little bit, and then the 1/2 is x minus 3. So what you're doing is just think about it, is you're breaking it down in terms of like prime factors. And you're circling on the prime factors without doing all that, without showing all that work. I just, how do I turn 6x squared into 12x squared times x minus 3? Well, it needs a 2 to get to 12, and it needed an x minus 3. Where'd the 5 come? 5 came from the original 5. Same thing here. We have the x still there, but how do I turn a 4x x minus 3 into a 12x squared x minus 3? Well, it had the x minus 3, it had one value of x, and it needed to be 4 turned into a 3, so it needs 4 times 3 to get me to a 12, and then an extra x. Okay.
So basically, you just take the.
It's just like I was, just like I was saying. It's kind of like taking the prime factors and you're circling what else does it need. Okay, what else does it need? I don't think anything works with negative 90 to 10, does it? I don't believe so. Every once in a while, you might find something. One thing that you could do is just throw in your calculator and find a 0. Because if you get a 0 that's at 3, then you know you're gonna have an x minus 3 as a term. See what I'm saying? Do you vaguely have any clue what I just said?
Can you repeat it?
Eh.
Can you repeat? I'm trying to figure out a way to can't manipulate me.
Could you reset it?
Well, if you were responding to so many text messages all the time, you'd probably pay attention better.
Me? I pay attention all the
What was it?
time. At home, by the way.
3x. Is it plus 10x?
He got you. He got you. You just got
did.
If I just go to my table,
He caught you.
if I go to what I'm looking for here real fast,
It was minus 30.
oh, is it minus 30? Wow. If I go to my table, if I have a 0 at 3, that means that 3 would have been a 0 and the term x minus 3 would have been a factor. What I'm doing here is I'm just looking for a shortcut. There is no 0 at 3, which means I'm not going to be able to factor that down to simplify. That's all I'm doing. I'm using all those rules of polynomials that we did about a month ago. It wasn't that long. Let's try another one here. Let's do one with subtraction. Believe it or not, it's a lot cleaner to see where all these terms are coming from when you don't have just numbers as well. It's a lot faster with just factors. It's a lot easier. So as you're writing the problem down, factor everything first. As you write the problem down, factor it. So I'd be writing down x plus 1 over x plus 2, x plus 2, minus 2 over x plus 2, x minus 2. And I'm trying to figure out least common denominator. Excuse me. So, fraction on the left has x plus 2, x plus 2, whereas the one on the right has x plus 2, x minus 2. So, what would be the common amounts of x plus 2's? Well, you have one in common, but what's the maximum that one of them has? So you have to have at least, you have to have the 2 of them over here. And what else is left? Kind of goes along the same lines as if you remember when you did the factor trees. If you had 1/8 minus 1/6. This would factor down into 1 over 2, 2, and a 2, minus the 1 over 2 and a 3. Well, the least they could have in common would be all 3 of them. And what's left? It's the same basic principle, but with terms. least common denominator between an 8 and a 6 would be 24. That's the smallest number they all go into. You're figuring out the smallest amount they could possibly have in common. That's all that is. So the smallest amount they can have in common would be 2 plus 2's and 1 minus 2. So fraction on the left, does it need to be multiplied by anything?
No.
Yes, what's it missing? It's missing an x minus 2. Fraction on the right needs an x plus 2. Now, one thing I will say is that when you're factoring these things through, leave your denominators in factored form. There's no reason to multiply them out. Leave them in your factored form with those terms like that. But numerators, you always want to combine like terms. Right. So you wind up with, let's see, x squared minus x minus 1, oh, excuse me, minus 2, minus 2x plus 2. So I have to distribute the negative of both those terms. So it winds up, oh, thank you. So you wind up with x squared minus x minus 2 minus 2x minus 4.
Is that multiplied by 2?
Yeah, because then you have to distribute the negative. Okay. I could have done that right off the bat by distributing the negative 2 to both parts. It means the same thing. Finally, you get x squared minus 3x minus 6 all over your x plus 2, x plus 2, and x minus 2. Yes, sir?
I think we have to do the x plus 2 for the times 2 because they already have.
It needs another.
Oh,
Because go back to the idea here. Excuse me. If I was doing the 8 and the 6, this one had 3 2's, this one had 1. This one didn't have a 3, this one has a 3. So this one needs just a 3. This one needed 2 2's. And that's how that would work. Same basic idea. Yes, sir?
How do you get that x squared on the way?
Yeah, in fact, I foiled out the x plus 1, x minus 2.
Oh, okay.
You always want to FOIL out everything in the numerators, combine like terms, and then just check to see if you can factor it. A lot of times you're not going to be able to. But what times what's negative 6 to get to negative 3? Nothing. Okay. Sometimes you might find something, but more often than not you won't. The solution sometimes in the back of the book would write the denominator as the quantity x plus 2 squared. Is it okay if you write it like that if you want? It's fine. Do you have to? You can leave them in factored form. Okay. Let's do another one.
Oh, wow. No, thanks.
Let's just jump right to the
ugly.
ugly.
Christmas tree.
Do you guys know what this is called?
I don't want to know.
It's
Now I
called a complex fraction.
I don't want to know what it's called.
It's called a complex fraction. Basically, this is fraction divided by fraction. Okay? So you can use your wambulins and whine and complain
I'm gonna need that.
about all.
How long does it take you to set that up?
I don't know.
Impressive. Impressive. So does that mean you have to set them all equal to 1 before you do the fraction?
I was, and even though I am happy about that, I still feel like crap. But it's just fun. Usually I have people looking outside. Wait. Okay. This, oops. In essence, this is the exact same thing as this. It's the same thing. It's some fraction divided by some other fraction. It's just written vertically, which means in the end, it's the same thing as saying 1/2 divided by 1/3, which is 1/2 times 3 over 1. So here is how I go about working with complex fractions. Do I need to do anything to the top fraction?
No.
No. It's one fraction. I don't have to, I can't simplify anything. I don't have to add things to it. I don't have to get a common denominator. I don't have to factor anything. That one's fine. So I'm just going to leave them alone. The fraction on the bottom, I have to simplify. What's going to be my common denominator between an x plus 2 and an x? Times x plus 2. Because there's a plus sign. Okay. So the common denominator is the same idea as you're multiplying the two together. 1/2, 1/3. What's the common denominator? 1/6. Or 6, excuse me, multiplying together. Same thing. So what I'm doing is I'm going to simplify the bottom part first. Fraction on the left, what did it need?
An x.
It needs an x. But it has to get a date first. I just thought of that. That was good.
It was not.
I don't know. Fraction on the right, what does it need?
X plus 2.
So it needs an x plus 2. So I need to simplify that one first. Okay.
So
Distribute out combined like terms. We're going to get x plus 2x plus 4, which is 3x plus 4. Everybody okay with that? I'm just simplifying the fraction here first, and just bring it right across. This is still over x times x plus 2. No, just leave it how it is. Yeah. Don't worry about foiling anything, especially in denominators, because look at what we have now. Now I have, you could probably, we have this 2 over x plus 2 divided by 3x plus 4 over x plus 2. Instead of it being that complex fraction where it's fraction over fraction, I'm going back to writing it horizontally, because what do I do with that secondary term then? Just flip it. So this winds up as 2, x plus 2, x plus 2, 3x, x 4. And now you're at a simplifying problem that we were doing 20 minutes ago. And what do you do?
X plus 2 plus.
Yeah, the x plus 2's drop out because they're a factor of 1. And this is the reason why you don't want to FOIL anything out. Okay? This is the example of why you don't FOIL stuff out until you're all the way done. Because now I have the x plus 2's that drop. My final answer is 2x over 3x plus 4. And I'm done. Can't do anything else. The complex fractions.
That wasn't even that bad.
Can we
No,
not do
it's
any
not.
more?
But you guys always freak out when you see it because
I
it
really
looks
don't
scary.
Well, it is scary.
That stuff is confusing.
What's that?
That stuff's confusing.
When I was going with the prime factors?
I'm confused on like why you do certain stuff.
Yeah, I don't understand that.
It's just another way of writing it. It's just another way of thinking about it. If you guys just think about it in terms of 8 and 6, what's the next number that both 8 and 6 go into? 24. So I almost try to use this. Yes, ma'am.
It doesn't have to be like the least common denominator, it just has to be common.
It does, but what happens if it's not the least, and this is a great question. What happens if you don't use the least common denominator? You'll have more simplifying to do later. So if I use this here and I just multiply them together, it'd be 48. Do you agree? So then that would be, so this would be what, 6 minus 8. So then I'd have negative 2 over 48, which is negative 1 over 24. So that tells me I had something that worked out better. But if I go through this and say, hey, it's gonna be 24, this has to be a 3, this has to be a 4, and I get -1 with 24. It's just one less step. But you're not wrong, but you can get lost if you start multiplying too many things out. That's all.
Well, how do you get to 6 minus 8 there? Like, what's the reason that it says 6 minus 8?
Do you agree with my comment? If I multiply those two together, it'd have to be 48.
Yeah.
Okay. What do you have to multiply an 8 by to turn it into a 48?
6.
That's why I multiplied top and bottom by 6 over 6. Because what's 6 over 6?
1.
This side you multiply by 8 over 8, which is 1. I'm using factors of 1 to change my numbers around. It's the same idea as when we did 1 over root 3. What do you multiply top and bottom by? Root 3 over oops. Because what's root 3 over root 3? 1. You do this all the time in math. You multiply by factors of 1 to change shapes of things. Okay, it's one of the properties that you can use. It's just a little trick. It's how you rationalize. It's how you do how you do basically everything. I think I have another one. Let's try another one like that. A little bit easier this time. So I have x over 5 plus 4. When you write these down, when you have just constants without denominators, throw them over 1 so you don't accidentally float the 4 to a denominator and accidentally turn it into a 1/4. I see it all the time. Don't do that. Don't do that. Actually, you wouldn't float it down, you'd be drowning it to the bottom. Don't do that either. So what's going to be my common denominator between a 5 and a 1? 5. So does the fraction on the left need to be multiplied by anything? No. Does the fraction on the right need to be multiplied by something? No. It needs to be multiplied by 5 over 5. So you get plus 20.
Okay.
Right.
I got you.
What's going to be the common between the 1 and the x? X. That's not going to be x plus because you're just looking at multiplying terms. All right. Oops. Fraction on the left, does it need to be multiplied by something? It needs to be multiplied by x. And I get that. Because the one on the right didn't need it. You already had the x. I'm just making sure you're paying attention. Sorry. Hey, you know what? If it took me until like 5 after 10 to make a mistake for you, feeling like poop, that's pretty good. Well, if you write 8 parentheses x, isn't that the same thing as 8x? Yeah. Okay. So now you have fraction divided by fraction. So you just multiply by the reciprocal at the bottom. So your final answer would be, well, is there anything I can do? No. Just multiply out the top and you'll be fine. X squared plus 20x. To be honest with you, when you get to something like this, when you know there's absolutely nothing you can be able to do, if you left it like that, that's okay. But usually you multiply out your numerator. It's not that scary, is it? Let's try one more of these complex. I know you guys get a little weird.
So we leave it just as that.
Is this one?
This is-
Uh,
or we are gonna go like that. So we do have to foil that last one.
Good show there. Well, I'll do it. Ah. So So I have 1 over 3x minus 4 over x plus 2, all over a whole bunch of other junk. Oh, Gabby. All right. What's give me the common denominator for the fraction up on top?
6.
Where are you guys getting this 6x from?
I don't know.
I don't know where you guys are getting this 6x. Would it just be 3x?
Yeah, okay. I don't understand.
You just multiply them together, done. Nothing else.
Oh.
That's it.
That's all you have to do?
Yeah.
All right.
Right.
Easy
Just
enough.
say that.
I hate that.
And now, fraction on the left, it needs a
X plus 2.
x plus 2. So it's 1 times x plus 2 minus 4 times 3x. Numerator, I get x plus 2 minus 12x. So that's 2 minus 11x. Is that?
Yes.
Now, I'm not rewriting that denominator over and over again because I know it's going to wind up here. Okay? And now I go to simplify the denominator's fraction. What's the common one going to be between x plus 2 and an x? X times x plus 2.
Whoa.
So, fraction on the left needs and I just simplified it out. X squared plus 1x plus 2. Is that factorable?
Probably.
What times what's 2 you had to get 1? Nothing.
Nothing.
Okay. So this is over. So finally, we have 2 minus 11x over 3x, x plus 2, times x plus 2 over x squared plus x plus 2. Notice I just flipped that bottom fraction right away as I started to rewrite it horizontally. Time saver. And what drops?
X plus 2
X plus 2's go,
and an X.
and an x. So you wind up with 2 minus 11x over 3 x squared plus x plus 2. And like I said earlier, you don't have to distribute out your denominators. You can leave it just like that. All right, need some problems.
So much space.
All right, so 9-4.
Or even, so. Could do lots.
Do those.
We're doing 27.
The 9-4 ones, it's just, those are all, it's a combination of multiplying and dividing, just instead of just doing, oh, let's just do multiply. Oh, let's just do divide. I just put it all together. Remember, order of operations when you're multiplying and dividing, what do you do first? Left to right, very good.
Either one.
No. I wasn't trying to catch you.
I was gonna take up the whole rest.
Just remember when you're writing down the multiplication and division style problems,
It's gonna take up this.
factor it as you're going, guys. It's just a little, it just saves a couple of steps, that's all. All right.
We have a late practice. Late practice? Like it goes later.